Well, I'm boring the pulley. For the tailstock. Got an indicator set up. Yeah, it's terrible to focus. And of course the travel stop. But everything's in the way. I'm trying to take a 5/10. Actually, I was trying to take a little bit less. And I got it 3-spoke hand wheel in a 3-jaw, and I got some paper in there, and it's a set true chuck. And it's almost through the bore. Alright, it took some. I had to retouch off with magic marker. Actually, let me... Sorry. Trying to feel it for the motor's off, I can stop. Feel it for cleanliness. Alright, where's my snap gauge? I left it in the super mic. So my last reading, I lay my snap gauge in the super mic. My last reading was 5/10 over the exact size of the shaft where the pulley's going to go on. Because I used where the end of the lead screw where that 7/8 feature is to set the super mic. So I'm 5/10 over. That's not enough. Let me pull this out and let me swipe it again. I don't know if you guys have ever played with this. Oh, geez Louise, you loosen it. This is a two-handed thing, and I don't have my tripod. Yeah. Let me measure it, and I'll bring you back. All right. I am 1 thou potentially over the nominal size of this, and I had to remove the boring bar. You know, I set it there, and so I can, you know, have clearance to stick this down in the hand wheel. And man, that is nice. I mean, that thing is just like, oh, come on, come out, baby. Come out, baby, come out, baby, come out, baby, come out, baby. Nice. Nice. All right, I'm going to face that. I'm going to stick this back over where it's not going to get bent. Because now that it's true to the world and the rim is, I indicated off the rim with my indicator on my holder, and it's a little beat up with just, well, beat marks. That's okay, I ran a file over it. Let me stick this back and we'll bring you more. Put this back so we don't drop it. All right, everything is so close tolerance. All right, let me play around with it some more and we'll bring it back. All right, guys, finally, finally, this guy is like done to where finally it's done to where it functions, okay? Now I got the hand wheel on here, and I've got this collar, split collar, right? So the handle's bored for 7/8, because that's what the butt end of this is. All right, can you see that? So the end of my Acme threaded feed screw brazed into that 7/8 piece is 7/8. The hand wheel, I bored this in that Pratt & Whitney lathe for 7/8. It's a through bore, no key, no nothing. It does have this 1/4" screw here, right? It's an offset 1/4 screw. And this Allen head screw, it screws into half of this collar, right? This is a shaft collar, a split lock collar that I made, right? Let's like, yeah, okay, come on. Well, this is not the way to go because it's going to screw up the up and down. But this is that collar I made. This is that tube that threads on to the body, right? And if you watch over here, it extends. Now this thing turns, there is no run out, man. I mean, this thing is like, maybe there's a thou run out on this hand wheel, maybe 2. That's in a sintered bronze bushing, and inside is that ball bearing thrust bearing. I need to put a handle on it. I was going to use this one, but I think this is 8" and I think this is 7. No, I think this is 9 and this is, I don't know what they are. This one's 7 and this is 7 3/4. That's interesting. 7 and 7 3/4. All right, whatever. But this one, it just seemed to be a nicer proportion. But this thing spins like butter, like glass, like butter on glass. I mean, this thing is just fine. Nothing could be finer than a tailstock built in Carolina? I don't know. Can you see? It's, man, yeah. It's rubbing my chain. It starts getting a little firm right there because the one end is bigger. Look at that, folks. 10 inches. 10 inches. So that's what we got. I'm happy to show this off to you. I think my battery's going to die. But anyways, no, don't want to gnarl it up with that gear. Acme screw works great. Thanks for sticking with me through this project. I might have an admiration video when it's painted and on the Hendey lathe. But thanks, guys. Appreciate you sticking with this project with me. Doozer Shop. Alright guys, welcome to Doozer Shop. I am high as a kite because I am calling this project done. And that is the tailstock for the Hendey lathe. And it's on there. and it fits beautifully. I'm just overjoyed. I thought about it. I first got the turn, ground, and polished rod bar stock 20 years ago. Isn't that silly? I got the lathe 20 years ago, and then shortly thereafter, at work they were throwing out some of this bar stock. And I think it's some kind of stainless. I think it's 17-4? 17-4, is that a type of stainless? I think it is. Because it don't rust when you put it outside in the rain for a couple rains. But anyways, 20 years I've had this lathe, and I started restoring it, and I got this piece of bar stock because the original spindle, quill, ram, whatever you call it, part of the tailstock, it was like 1.5 thou loose. I mean, you could wiggle it. I mean, it was wore out, but the iron body, cast iron body, seemed fine. So, and I knew it was 1.5 inches, and I took a guess that this turn, ground, and polish would fit. And when I got it, it almost would insert into the tailstock. So I knew it was very close. So that's why umpteen years later, I ended up using it, and then I had to make that aluminum block to outside diameter hone it, which is cool. That OD honing video, as of now, that's over 500 views, and most of my views are like 250. So a lot of you guys are interested in OD honing with that lap I made. I guess it's OD lapping. I mean, it's not honing. I'm not sure what it is. Leave a comment. All right, enough talking without showing you cool stuff. Let me point the camera at the tailstock. Let me get it all in frame. Right? Okay. Okay, you can't see me, but you can see the tailstock. And I'll pick it up and do a little bit of handheld in a little bit. So, I got a center in there, just for the heck of it. So 2 Morse taper with provision for the tang, the anti-rotation tang. Originally the hand wheel was right on the butt end of the tailstock, and this tube is the extension that houses the quill when it's retracted. I forget what this is. I think this is 2 3/16 inside and 2 3/4 outside. I forget. But this is DOM, drawn over mandrel tubing, seamless tubing. I bought this on eBay as a drop, 10 inches long. It's 10 inches from stem to stern. So anyways, I just want to make sure you can yeah, you can see this. So this thing glides like butter, right? I mean, it's like butter. Now watch this side. Okay. I mean, I'm gonna run this thing out. I mean, it's gonna go out of frame, dude. I mean, this thing's gonna just keep on growing like Pinocchio's nose, eh? That's about 8-9 inches right there. Yeah, it's almost off the frame. So with this sticking out 9 inches, okay, it is still fully supported inside the cast tailstock housing, okay? So this 1.5 inch bar, which is my quill or spindle or whatever, I think it's like 18 inches long. So if that's like 8 and this is 10, It's right there. It is right there at the back, fully engaged, you know, for rigidity and support and you know, in the tailstock. Where before, the old quill was 9 inches and change. So the old quill, when it would stick out 4 inches, it was only hanging out 5 inches in the tailstock. See this oil cap, this oil port? The factory Hendey tailstock quill, I got it over on the other bench, I should have brought it. It would end up right there, just where the oil slot would not be uncovered by the quill and dump the oil, you know, inside where it wasn't supposed to. So I really didn't plan on making this thing this long, but I had the material and I was like, why do I hate to cut it, right? And for no, I should say, I'm getting ahead of myself, no more trouble than it was, but it was a bit more trouble. To leave it long, I could have full support in here. Now, is that super important? No, it's not super important. But it's going to be less chatter if you're drilling, right? Because this is the lock, right? This is the lock. And if it's locked, it's locked. Not only less chatter when you're drilling, but the fit is so close in here. I am within 2/10 shaft, spindle, whatever you call it, to bore. Between 2 and 3/10, about 2.5 tenths, right? Run this back in. I mean, this thing is very chatter resistant. And also, when you extend it out, the geometry, because of this nice, tight, new, honed, lapped bore fit, it's going to stay right in that center line of alignment, right? Because this is so nice and tight, and also the bearing is a full contact length, not half or whatever. The geometry of the spindle being on center and not sagging or drooping as they often do, that's not going to happen. I mean, it's going to happen so minimally, it's going to be, you know, before I was an engineer and a machinist, and, you know, you used to use the term, you know, it's so close, it's within the thickness of a hair, right? Well, the thickness of a hair is like 3/1000ths, and the fit there is like 3/10 between the bore of the tailstock and the spindle, the quill. So 3/1000ths of a hair versus 3/10 of a thousandth, it's 30 times smaller, finer of a fit than the thickness of a hair. So the thickness of a hair is 30 times bigger than the clearance between the bore and the spindle. I mean, that blows my mind to think about it. But, and another thing, it's hard to describe because I measured this thing at 1,000 points, right, just throughout my building. It'll go out about 10, 11 inches. I mean, am I off camera? Or I'll just, you'll see it. I mean, I gotta move my tool post, my carriage over. I mean, that's, so, right there, right? I am about 1 foot, 12 inches. And I'm still inside here by, you know, like a good 6 inches. It's just right there. I could go more. It starts to get a little more tight, okay? So when I made this spindle, quill, and I decided which end am I going to flip it which way when I bore the Morse Taper 2 socket, and which end am I going to bore the Acme nut side. I put it in both ways, and I want, and this is just slightly a 1/10 bigger on this side. So I put the side where it's a 1/10 bigger inside, you know, towards this direction. So when you get out this far, it actually starts getting tighter. The fit gets a 1/10 tighter. So, I mean, it, you know, I tried thinking of everything, you know, with this. So like I said, I'm sticking out a foot. Oh, sorry. I'm sticking out a foot, and I still got, you know, about 6 inches inside the tailstock body. You'll never need to drill a foot deep. I mean, don't say that, because I drilled this whole thing from stem to stern. I drilled 19 inches. Actually, I drilled, you know, half of that twice, from one from each side, and I met in the middle. But it's pretty neat, and it gets easier right there. So this whole, I'm talking loud because I get excited. So this thing is smooth like butter on glass. It just turns so easy. And watch, I'm going to pop the eject, right? And now I can just bloop, take it out. Right? And it self-ejects. Boop. Right? But it does go flush. Right there. And like I said, a tang, with a drill bit with a tang can go in there. It's pretty nifty. So let me show you, this is sort of a review, like project review, right? So let's look here, okay? Let's even bring it in. Let's even drop you down. Now, I'm going to loosen this. Okay. And I want to show you these threads, man. So this is one of the first things. Is that, yeah, let me crank this out a bit. All right. One of the first things I did was cut these threads. And I got a video, of course, in my videos about this. Right? So there's the threads that I cut. And I'm trying to remember. I think this thread ended up being 2 3/8 12, or 2 3/16 12. I forget. I think it was 2 3/8. But this whole cast tailstock body was spinning around. I know you can't see. In the Colchester lathe behind it. And actually, there's internal threads where the factory end plug used to go. So everything you see here, this cast iron tailstock body with these threads on it, these threads cutting the cast iron body, this was just a smooth, you know, the gray part was just smooth to the end, right? And I turned this straight until I got clean up on the casting, and then I cut these threads. And I shut the lathe off when I was about, you know, 2 or 3 threads shy of the end, and I just kicked it into neutral, and I hand spun that big 16-inch 4-jaw chuck to cut this threads, you know, right to the stop. And somewhere the thread just dies at an abrupt dead end, you know. So let me close this back up, thread it back on. And this thread fits tight, dude. It's like a 1 or 2 thou fit. I mean, this thing is just, you know, I really took my time. Done. Done and done. Right? Let's come over here. And so actually, let's go a couple inches more. So inside here, you know, I got these 4 screws. That's just a hockey puck of steel. And it ended up being 600 wide after I faced it. I think I surface ground it. 600 wide. So these 4 screws are 300 from the edge, spaced with my indexer as you watch my previous videos. So that's what holds it in there, this end plug. And you may be able to see that bronze head of a bushing. It's a flanged bushing, sintered bronze. It goes in, I think, a 1-inch hole in this, I call it the hockey puck end, in this tailstock butt end. And it's got a 7/8 reamed, you know, internal hole. So the ultimate inside diameter is 7/8. That's what the shaft that grafts to the Acme rod is. It's 7/8. So this collar, this is a clamp collar. Can you see the split and the bolt? It's a split collar. Those threads, split, and then the bolt head again, right? So I just made that up. And what this collar does is it takes the retraction force. So when you're screwing it in, like you're drilling or applying force with a center, on this side of the end plug is a ball bearing thrust bearing. It's a ball bearing thrust bearing. But when you retract it, when you're trying to eject a center or eject a drill or a chuck, it's pulling back on this collar. So this collar sets the end play, and it takes the pull-out force when you're trying to eject. It doesn't take the force of the tool because that's absorbed by the Acme nut. It pulls the quill or the spindle back. And also, that 7/8 split collar, I got it in an axial tapped hole, not coaxial, but axial, to retain this hand wheel, this aluminum hand wheel. And that's an old, some set screw hole that's not used in this application. So let me turn the camera, if I may, onto this hand wheel. So this hand wheel, it's an aluminum hand wheel. I think it's off of a Noble West roll marker, of all things. But here's that Allen head 1/4-inch screw, and this hand wheel is just bored for 7/8 slip fit, and the only thing that keeps it on here, other than the bore of 7/8 on the that adapter shaft, is this screw, and that takes all the it keys in the torque and everything, and it holds it on. So really that clamp collar is doing all the locating and the absorbing the forces, and the hand wheel you know, rides on the shaft, and it's affixed really with that single screw. Okay, so let me zoom in on that shaft right there. So, and this is a little bit of a review. So this 7/8 stub shaft, I needed some way to adapt the Acme screw, which is 1/2 inch. So you'll see it has the center hole in the Acme screw, and then you'll see a little bit of that thread profile with the bronze braze around it. So that's what I did in order to get the diameter of that 1/2 inch Acme screw a little bit larger so I could put on the thrust bearing and, you know, the bushing in the butt end of the housing, and attach the hand wheel and that clamp collar. I had to make it bigger than the threaded 1/2 inch Acme, because if you think about it, the minor diameter of a 1/2 inch Acme thread it's like 0.369. It's like under 3/8. So that's really small to put all your thrust bearings and your hand wheels and whatever on. So that's what I decided to do. I turned a piece. It ended up being 15/16 or something like that, and I turned it down to 7/8 after I put the step in it, because you need a step for a, you know, a wall, an edge for the thrust bearing, the ball thrust bearing to push against. But it ended up being 7/8. So that's what you see here. In this 7/8 shaft, like I said, when I brazed it, it was 15/16, cleaned it up to 7/8. There's a counter bore in this shaft, this 7/8 shaft. I think it was 0.65 inches, a little bit bigger than 5/8, not quite 11/16, because I had some 21/32 end mill, whatever. So I counterbored it. I went a little more than 1/4 inch deep, and I filled it full of braze. Okay, so that was my solution to making a hub, right? I had to put a hub for mounting the bearings and all that stuff on the Acme screw. So that's what I chose to do. Drill a hole right through the center and braze it on the back side. So drill a 1/2 inch hole for that 1/2 inch Acme screw, and I brazed it on the back side. Okay, pretty neat. So let me back you up here, and I got this nice handle. This hand wheel didn't have a crank handle, so this I had, it was a cast off. This was actually a rotating member, a rotating piece from another hand wheel, and I made just a spindle for it, and I Loctited this little spindle inside here in the nicely teardrop shaped piece, and I Loctited it. There was a hole existing in the aluminum hand wheel. So kind of neat. If anyone knows this style of hand wheel, or who made this pattern with the 3 little sergeant bars or whatever you call it, I've seen these used on DC Morrison key seaters, I think, and Powermatic used, I think, this style of handle. I'm always interested to know the manufacturer. Like Carlane made handles. Like Reed Supply has handles. I can't think of all the names. Destaco made clamps and handles. But if anybody knows the name of this aluminum hand wheel, drop in the comments. And man, if you can see, I'm going to try and shoot this. Look how rough and knickered up the surface is, right? But I like it. I ran a file across this, and I like it a lot. It's smoothed out, but it's got all this character, right? It's pretty neat. All the use marks on this hand wheel, you know. So I thought that was fun. I'm gonna go handheld here. I know you love that. Oops. I don't know what else to show you. I kind of gave you the detail here. These are all freed up. Dog points on these. This is to shift the tailstock from side to side. Let me give you around the back shot. That's the binder that locks it. It's got a quick locking action underneath, which is kind of cool. And this is the quill lock. So that's free and that's locked. Okay? And the other offsetting adjustment there for side to side. I think that's for a quill, oil quill dipper to lubricate your live center, maybe. I don't know. Had to do some work. So this handle is attached to some cotters, and this is an indexable screw head. There's 12 positions on the cotter, on the face of the cotter, and that's like a 1032 grub screw, a set screw rather, that you adjust it and then you tighten the dog point into one of those index holes. Now it's interesting, see how this has a slot in it? Well, Hendey did not have a slot. I made that screwdriver slot because there's no way to turn that thing to adjust where this ends up locking, right? That's unlocked, and there's a tension adjustment where you want this thing to go, you know, a couple degrees. But anybody else that has a Hendey T&G, you might want to slot that because it makes it way easier. And just the front here, you can see the Collis 2 Morse taper insert that I secured with green Loctite. It's black oxide in the middle, so it's hard to see. And notice on the front, the 3 screws hold some felt wipers that keep the ways lubricated. And there's little ball oilers. You can see a little piece of felt hanging out. And I had to make new felts. And I had to punch those out and razor blade cut them. And there's actually 2 pieces of 1/8" felt glued together with wood glue to make it a 1/4 inch thick. Oh, and this top lubricator was a ball lubricator like that, but it wasn't itty bitty 3/16. It was 5/16. But I tapped it for 1/8" pipe thread, and I got a little reservoir, and I got some oil in there. And I think I maybe mentioned this, but because the oil is so the fit is so tight, I'm using this Blaster penetrating lubricant because it's just it's a nice light viscosity lube. Anyways, well, there you go. The project's finished. I really like the looks of everything and how it came out. Let me back up even more. There it is, folks. And you still get the full 24 or 26 inches between centers. So anyways, hope you enjoyed this project. I learned a lot about precision. Everything is concentric and, you know, true within 2/10 or less, as close as I could get a reading on indicating the surfaces and alignments. This thing was, it goes together and comes apart like a joy because everything is so precisely made. So thanks for watching this journey. This is Doozer Shop.